Welcome to Write an Expression. Now we skipped the group activity of the tiles because I don't know how to facilitate a group activity online yet, so that's something I'm going to be looking into. But Write an Expression is really where we're going to be getting more into the algebra that we're going to be seeing over the next little bit. So I'll give you a chance to read this thing, but algebra really makes the problems easier. And it's how we're going to make sense of things. So first thing I want to note here is this. Now, consecutive odd integers. Integers are whole numbers, positive and a negative, and consecutive means next to. So if we have consecutive odd integers, like 1 and 3, or negative 3 and 11, if we name the first one x, that is if we said this 1 right here is x, we notice the one after that is 2 more than that, so that could be x plus 2. Same thing with this negative 13 and negative 11. Those are consecutive integers. If that one's x, how do we get from negative 13 to negative 11? Add 2, so the next one is x plus 2. So now we're going to do a little bit of practice here. So, name the sum of 3 consecutive integers. Now, 3 consecutive integers would be like 1, 2, 3, or 4, 5, 6. They're right in a row. So as opposed to these consecutive odd integers where the spacing between them is 1, the spacing between these is 2. So if we had the first integer, like the first one we could call x, the one after that, like 2, is 1 more than this first one, so we could call it x plus 1. Now 3, because we've defined 1 to be x, 3 is 2 more, so the second consecutive integer after our 1 will be x plus 2. So this right here is how we denote 3 consecutive integers. And you can see if we put 4 in for x, plug 4 in here, that's our 4. Plug 4 in here, that's where we get our 5. Plug 4 in here, that's where we get our 6. So the other thing is this. In mathematics, sum means add. So we want to add these 3 consecutive integers together. X plus 1 plus x plus 2. So that is the sum of 3 consecutive integers, with this being the first, this being the second, and this being the third. Now, we can combine like terms on these. That is, we haven't really talked about this, but if you have 1x, 2x's, 3x's, we could write that as 3x. We could add the numbers together as well. 1 and 2 is 3, so 3x plus 3. That would be kind of a compact way to write that. And this is stuff that we're going to be getting more and more into as we progress through this class, so I figured I'd introduce and just talk about it briefly now. So, once again, twice the sum of a number and 8. So twice, we're going to multiply something by 2. Sum, once again, means we're going to add. The sum of what? A number and 8. Now, anytime we see a number, we can just let that be the unknown, the variable. And generally, we'll denote this as x. And notice it says the sum of an unknown number and 8 would be 8 plus 2. But we want twice this, so we'd have to multiply the whole thing by 2. And that's what we're getting. So, we're going to practice these following. So if we have twice a number is x, twice is 2, so that's just going to be 2x. 5 more than a number. So more than, we're adding, so 5 more than a number is going to be x, that's x plus 5. Now the difference between 7 and a number, difference means subtract. So the difference between 7 and a number, that would be 7 minus, for difference, a number we're translating into x. So 7 minus x. That's an expression right there. And then we have the difference of twice a number and 12. So difference, we're talking about subtraction again. I'll put some subtraction down. Now, twice a number, okay? Twice a number is going to be 2x, and 12 is 12, so 2x minus 12, that's what we have there. Now notice, the next one says twice the sum. Here we had the difference between twice a number. Twice here is referring to the number, and that's why we have the 2x, and there's not parentheses like we had in the beginning. Here, if we have twice the sum of a number, we're doubling the sum. That's what this twice is referring to. So the sum of what? The sum of 8 in a number, 8 plus x, and twice that, we have 2 times that whole sum. So that's why we need the parentheses right there. Okay, so let's just continue through here. Bryn has a total of 29 pets. If she has cats and chickens, name the number of each. Make one of the unknowns X. Okay, so if X is the number of cats, the total number of pets is 29. The number of chickens should be the total minus the number of cats. So this should be a 29 right there. That's a typo, but that's what we have. And we can think about it like this. Like, if there's 29 pets right there, and they're both chickens and cats, if we take X of these away to be the cats, what remains? Well, 29 minus X. So there's 29 total minus the ones we took. That's how we're getting that right there. Okay? So now we have a little geometry problem. The length of a rectangle is 5 more than the width. Okay, so I'm just going to denote L to be length and W to be width. So just denoting those right now. And I would write this out, but I'm a little tight on space right here, so I'm just going to leave it at that. Now, we're going to directly translate this right here. So it says the length of a rectangle, so the length of a rectangle, L, is always means equals. So length is 5 more than the width. Well, 5 more, we're adding 5 to something. We're adding 5 to the width here, so that's W plus 5. And this is exactly how we would write the length is, meaning equals, 5 more plus 5 of the width. So, now, express the perimeter of a square with an unknown side. Okay, so a square, we all know what a square looks like, but one interesting thing about the square is that this side, we'll call it a length of X, so that's side length, is going to be the same as that side length, which is the same as that side length, which is the same as that side length. So all the sides are the same. Now, if X equals one side length, the perimeter is the total distance around. So if we start here and walk, that would be X, plus another X would be 2X, plus another X would be 3X, plus another X would be 4X. So the perimeter, we could say P is perimeter, equals 4X. And that is going to give us exactly what the perimeter of a square is with a side length X. Okay, so next one we have, Bob makes $18 an hour. Wow, I kind of wish I was Bob now. Bob makes $18 an hour. Express how much he would make in terms of number of hours he worked. So how much you make is in terms of how many hours you work. So we need to define a variable for hours. Let's say H equals number of hours worked. Since he gets $18 for each of these hours, we can define his pay to be 18, the dollar he makes per hour, times H, the number of hours he works. And that right there is a perfectly valid equation for how much pay he gets. Okay. So, just kind of cruising through these. Use one variable to express the unknowns in the given problem. So, Don is 7 years younger than Terry. If Don's age is X, if Terry's age is X, how old is Don? Well, Don is 7 years younger than Terry. So if Terry is X years old, Don being 7 less than those, we're going to have to subtract 7 from that. In this, we'll say equals D, or D for Don's age. Now, if Terry is X now, how old will she be in 10 years? Well, if you're 13, how old are you going to be in 10 years? Well, 23. How do we get that? Add 10 to the current age. So if Terry is currently X years old, we can add 10 to that, and that's 10X. Now, here we're asked, how old was Dawn 5 years ago? Well, we look back up to this first question. Dawn is X minus 7. So currently, she's X minus 7 years old. So 5 years ago, to figure that out, we're going to have to take another 5 off, which means that Dawn 5 years ago was X minus 12 years where X is Terry's age. So this is all in terms of Terry's age. Now, excuse me, for the last problem, we want to know what is the sum of Don and Terry's age. So Terry plus Don, because once again, sum means add. So Terry, we defined her to be X. So we have X. Don, up here, is X minus 7. So really what we're doing is this direct substitution. If D equals X minus 7, wherever we see a D in a problem, we can write X minus 7. Since Terry equals X years, wherever we see a T, we can write X. So this is Terry's age plus Don's age, which is X minus 7. Now, we can combine these terms again. If we have one X and we add another X to it, we have a grand total of 2 X's, which we write as 2X. And we have our minus 7. And that is the answer to that one right there. So, I'll pick up the rest of these problems in the second part. I hope you enjoyed it. See you soon.